In this lecture, we will learn about reshaping and resizing Numpy array. Also, we will know about Ravel and Flatten function. Using the reshape method of Numpy, we can give a new shape to an old array. Let's say we have an array with shape 3 by 6. So let's declare a variable np array and create a Numpy array 3 by 6, print it, now if we want, we can reshape it using the reshape method of Numpy. So we can say np array dot reshape, and we can pass a new shape, like we can say 6 by 3, and we can see the array is reshaped. It's now 6 by 3, 6 row and 3 columns. Let's try 9 by 2. Awesome, it's working perfectly. What if we want to make it 5 by 4? Let's try it. And we are getting an error. It's saying cannot reshape array of size 18 into 5 by 4. Well, when we give a shape to an array, it takes indexes, elements based on its shape. Like if we give a shape 3 by 6, then it will take 3 multiplied by 6 means 18 indexes and elements. So we can reshape this array and make it 6 by 3 because 6 multiplied by 3 is 18. We can also make it 9 by 2 or 2 by 9 because 9 multiplied by 2 is also 18. But we cannot make it 5 by 4 because 4 multiplied by 5 is 20. And now let's look at the resize method. The resize method also works in the same way, but there is only one difference. Like we see in view and copy method, the reshape method reshapes in shadow. It does not reshape in memory. And the resize method reshapes in real. So let's try to print the np array without reshaping. We have already tried reshaping 2 times, and now let's print it without calling the reshape method. And we can see in reality it's an array of 6 by 3. Though we have reshaped, but it was in shadow. So if we want to reshape an array, then we have to assign in another variable. But the resize method works in real. So let's try it and say 3 by 6 and print the array. Sorry, it was in real 3 by 6, so we can say 6 by 3 and print the array again, and this time we can see it's affected in real array. Well, the Ravel and Flatten method both converts any multi-dimension array into single dimension array. So let's try it. Let's try Ravel first. We can see the array is converted into single dimension array. Now let's try to print the array without the Ravel method. And we can see the main array is not affected. What about the Flatten method? It's the same. It's converting into single dimension array. Let's try to run the array or print the array, and the main array is not affected. So what is the difference? Actually, the Ravel method works like view method. If we assign an array into another array using the Ravel method, then it converts into single dimension array, and if we make change in any of the array, then both the array is affected. So let's try it. Ravel np Ravel array and make change in main array row 0 column 0 till end. We want 1 1 1. Execute it. Print the main array. Now let's print the np Ravel array. What about the flatten method? The flatten method also convert any multi-dimensional array into single dimension array, but it works like copy method. So when we convert any array using flatten method and assign in one variable and make change in one of them, then only the particular array is affected. Let's try it. So np flatten array and np array dot flatten. Execute it. Make change in main array. So first row, first column, and we want actually to affect all the columns from first columns. Sorry, all the rows from first rows. So here, let's say we want to assign 999 here, 999 here. Execute it. Print the main array. It's affected. And now let's print the np flatten array. What about the np Ravel array? Now let's learn about arithmetic operations and aggregation functions in Numpy array and do that in next lecture. But before that, do subscribe the channel and leave some great comments to inspire me.